Multiply 6 by 13 by the reciprocal of minus 7 by 16. So what will be the reciprocal of minus 7 by 16? If this is minus 7 by 16, then its reciprocal will be 16 or minus 7, right? What we do is we simply interchange the position of the denominator and the numerator, right? And we know that reciprocals are also called multiplicative inverse. Right, now this is 16 over minus 7. This 16 over minus 7 can be written as minus 16 over 7, and this I have repeated several times, so let me repeat one more time. If your rational number is of the form p over minus q, then this is actually equal to minus p over q, and this can be written as minus in the center, then p over q. These three are the same thing. Okay, so minus 16 over 7, if you multiply minus 16 over 7 with 6 over 13, because we have to multiply by the reciprocal of minus 7 over 16, so this is minus 16 over 7, you get minus 96. 6 times minus 16, or let me write it here, 6 times minus 16 and 13 times 7 minus 96 by 91. So this is your answer. Tell what property allows you to compute 1 by 3 multiplied by 6 multiplied by 4 over 3 as 1 by 3 multiplied by 6 multiplied by 4 over 3. Now, in this example, you can clearly see that in this first one, if you assume that this is A, this is B, and this is C, and in this case, it's actually A times B times C. It is A multiplied by B multiplied by C, right? But in this case, if you notice, it's actually A multiplied by B multiplied by C. And it is asked that tell what property allows you to compute as this one. If you look at this and this expression, these are actually equal, right? And it's what? It's associative property of multiplication of rational numbers. This is associative property of multiplication of rational numbers. Of multiplication. It's important to write multiplication because there is an associative property for addition of rational numbers. Multiplication of rational numbers. Is 0.3 the multiplicative inverse of 3, 1 by 3? Why or why not? Now this 0.3 can be written as 3 divided by 10. 3 by 10. We know this, right? We have learned this. Now 3 by 10, you have to tell whether this is the multiplicative inverse or reciprocal. We know that multiplicative inverse is also called reciprocal. So 1 by 3 can be written as, this is a mixed number, so this can be written as 3 times 3 plus 1 divided by 3, and you get 9 plus 1 divided by 3, you get 10 by 3, right? So the multiplicative inverse of 3, 1 by 3 will be what? You have to interchange the position of numerator and denominator. So the number you get is 3 over 10, and that's exactly what this is. Yes, zero point 0.3 is actually the multiplicative inverse of 3 1 by 3, because 3 1 by 3 can be written in this form, and when you simplify this 0.3, if you write in the form of fraction, this is actually 3 by 10, and these two numbers are the same. The rational number that doesn't have its reciprocal, you have to tell the rational number that doesn't have its reciprocal. Now, if you remember, when we were learning about reciprocals, at that time we discussed that 0, the number 0 does not have its reciprocal. And why? Because we say that, let's say any rational number is a over b, a by b, then its reciprocal will be what? You have to interchange its position, and that will be reciprocal, or multiplicative inverse will be b by a. Now, a number 0 can be written as 0 over 1. We have learned this. We can represent the number 0 as a rational number. It can be written 0 over 1, 0 by 1, 0 by 2, 0 by 3, and so on. Because it doesn't matter by what number you divide 0 with, the result will always be 0. That's the same thing, right? Let's choose this one, 0 divided by 2. Now, if I write this number 0 as 0 by 2, then what will be its reciprocal? We have to interchange the position of the denominator and the numerator. This becomes 2 by 0. But we know that this form is actually undefined. It is actually undefined form, because we cannot divide any number by 0, because that is undefined form. So the rational number 0 doesn't have its reciprocal. The rational number that are equal to their reciprocals, here should be rational numbers, the rational numbers that are equal to their reciprocals. Now, think for a moment, what rational number comes to your mind that is equal to its reciprocals? Instantly, 1 should come in your mind. If this is 1, this 1 can be written as 1 divided by 1, 1 by 1, right? So, if you interchange the position of the denominator and the numerator, this again becomes 1 by 1. It's ultimately 1 only, right? So we can see here 1 is the rational number whose reciprocal is actually equal to the number only. Now there can be another number. Pause and think what that can number be. That number will be -1. Why? Because -1 can be written as what? -1 divided by 1. You divide any number by 1, you are going to get back that number only. Now, if you have to write its reciprocal, you have to interchange the position of the numerator and the denominator. So this number becomes 1 over -1. Now we know that this can be written as -1 over 1. It means it's coming back as -1 only. So we reached from where it started. We reached to a position from where we have started, right? So this is same and this is also same. So 1 and -1 are the rational numbers that are equal to their reciprocals.